Spunstrand fiberglass duct is manufactured in Wallace, Idaho, made in the U.S. for over 50 years, with thousands of miles of duct installed in all kinds of job sites around the world. Spunstrand ducts are engineered and manufactured to be installed watertight, leak-free, and to outlast the projects they serve. In the 50 years, we have several buildings demolished and discovered ductwork underneath the slab still in new condition. To help show you how to install our duct to last, we will cover the major points of our written instructions and demonstrate the factory-trained methods we have developed in our long history. This video is not intended to replace our installation manual and should be used as a visual reference to support the installation of your projects. When joining two lengths of underslab duct, ends must be lightly sanded to prep for the wet layup joint. Be sure to select the correct length of sheet metal screw for the thickness of the insulated or non-insulated duct. Have your sheet metal sleeves cut to an overlapping length. These should not be preformed to allow for a perfect inside diameter match. Insert the sheet metal sleeve into one end and secure with self-tapping sheet metal screws. Enough screw should be used to secure the sheet metal sleeve and fiberglass ends, roughly every 6 to 11 inches around the circumference depending on diameter. Slide the adjoining piece of duct onto the exposed half of the sheet metal sleeve and secure with matching sheet metal screw. The factory supplies resin, glass, organic peroxide, and catalyst, in addition to a starter kit containing items required to join the ductwork using the wet layup method, with the exception of acetone for cleanup and wax paper for a clean and transportable wet joint layout surface. All of the provided joint material items must be put in a clean, dry, and warm location. Please review all MSDS sheets, written labels, and instructions prior to beginning field joint assembly. Supplied starter kit will only allow for a small number of joints. You may need to furnish additional supplies depending on the size and scope of your project. These supplies, as seen in the provided starter kit, can be found locally. Once your duct has been joined and secured with a sheet metal sleeve, the duct can be placed in the trench on top of a minimum of 4 inches of pea gravel or dry silica sand, which is used to support the duct in a level trench. Assemble as many joints as possible with sleeve and screws only, so more than one joint can be executed with a wet layup assembly. Due to the light weight and strength of the fiberglass, long or multiple sections can be joined prior to lowering into the trench. This allows for fewer joints to be assembled in the trench environment. Wipe down the area to be joined, removing all excess fiberglass particles from the duct surface. The joints in the trench must remain clean during layup. This can be accomplished by sliding a sheet metal sleeve underneath the area to be joined. This will allow you to pass the wet glass material under the duct without dragging it through the fill material. Pour the resin into the bucket, mixing only enough resin to secure the joints that can be completed within 20 to 30 minutes. Reference your catalyst to resin chart based on the ambient temperature in your environment. Add the organic peroxide catalyst to the resin and mix thoroughly and quickly with a stir stick. Once the catalyst is mixed, immediately start applying to the pre-cut sections of glass mat material required for the diameter to be joined. This is being done on a clean, disposable surface. Thoroughly work the resin into the glass. Lay down the first and widest section of fiberglass mat. Chop strand up and wet out with a complete resined catalyst mixture. Working the resin through the dry fiberglass mat. Once complete, place the second mat on the saturated material with the woven side down and wet it out. The chopped mat will be the side bonded to the duct. The woven side will be exposed and visible on the exterior of the finished joint. Wax paper should be used to transport the saturated fiberglass material to the duct seam to be applied. Slide the wax paper and saturated material under the duct seam, keeping the wax paper on until the wet joint has fully contact with the duct. This allows the joint material to stay clean during the curing process. Use the serrated roller and brush to remove any entrapped air and apply extra resin to all dry areas on the joint, especially over the screw heads. A heat gun or external heat source can be used if temperatures are below 50 degrees Fahrenheit. It is not necessary to completely cure the laminated area with the heat gun. only to start the gelling process. The joint will start to heat cure and lose its tackiness on the wet surface. Be aware most lengths of duct carry a directional arrow for airflow and a Radco label displaying our code approvals. Leave these visible on top of duct when placing in the trench. A building inspector and engineer will check for compliance. Saddle taps are available as an alternate to T's or laterals. They are attached with the same wet layup method using screws to secure the saddle tap to the adjoining ductwork. Place the saddle tap on the duct and mark the diameter of the hole to be cut with a permanent marker. Cut the marked hole with a jigsaw or saber saw using a carbide blade. Place the saddle tap centered over the opening and secure with self-tapping sheet metal screws. Sand or abrade the surface where the wet layup will be applied. Mix the resin and catalyst and apply to the glass mat in the same manner used for the duct joining. Apply small sections using the serrated roller to help guide the material around the tight circumference of the tap. Roll out and apply resin to any unsaturated glass materials. Tools, such as brushes and rollers, need to be kept clean for reuse. Soak and clean with acetone in a properly labeled plastic bucket. Resin, liquid catalyzed resin, and acetone should not be stored in open containers when not in use, and should not be left unattended, especially when indoors. Cured resin discs in or out of a mixing bucket is inert and may be disposed of in common waste receptacles. Uncured resin, leftover organic peroxide, and acetone may be disposed of using proper OSHA, MSDS requirements, prevailing job safety, and local standards. Backfilling may begin once all joints are cured completely, preferably after a minimum of a 24-hour period. Before backfill may begin, visually inspect the entire trench for even support underneath the duct. Make sure all large rocks or sharp objects are removed. Bring the pea gravel or dry silica sand up to a minimum of 4 inches on all sides of the ductwork. The maximum depth of burial for standard Spunstrand underslab air duct allows for a 5 foot of backfill cover from the crown of the duct to the bottom of the slab. Deeper burial is possible, however, your Spunstrand representative must be contacted for special requirements. Pea gravel or dry silica sand, as dumped from a wheelbarrow or trickled from a loader, will reach approximately 85% compaction. With the addition of hand tamping or rotting, pea gravel or dry silica sand will reach the necessary 95% compaction. Make sure your trench has adequate slope and/or drainage to keep water from building up in the trench and potentially floating the ductwork before the slab can be poured. After backfill is complete, either bridge or stake the trench to ensure no traffic is allowed to pass over the ductwork until the slab is poured.